Okay, so do you guys remember what these things are called? Absolute value. My last class might have had a little bit less of a memory of this. Do you guys remember what absolute values do? Yeah, Kevin?
No matter what the number is, it'll always be positive.
Yep, no matter what number's on the inside, we always make it positive. It always brings like a positive part to your day, always takes it positive. So our first one, we have a negative 15. What's that going to end up being? Yep.
15.
Yep, it's just going to be that positive 15. That's correct. Okay, after that, our second one, we have 7. What happens to the 7? Yep. It just stays the same. Thank you. Now we have an operation happening inside the absolute value. So we got to do the operation first. So we have 10 minus 34. What do we get when we do 10 minus 34? What did you say?
24.
We end up with that negative 24. It's our absolute values. And then she told us the answer is going to be 24. And then after that, we have one more that has an operation happening in it. Negative 12 minus negative 2. What happens when you subtract a negative? Yep, it's the same thing as adding a positive, so I'm going to switch these signs. Negative 12 plus 2. Yep, negative 10. The absolute values turn it into a?
2.
Yep, nice job. Okay, after that we have plotting points. I brought my coordinates sheet up here because I didn't have one on my page. I put it on yours. So our first one up, we want to talk about 2, negative 5. So remember the 2 represents the x direction. So this is our x axis, y axis. So we have 2, negative 5. So we go over 2, down 5. 1, 2, 3, 4, 5. And we put our first point here. And this is question number 5, so I'm going to label it 5. Our next one up, we end up with negative 3, 7. Negative 3 is on our negative side of the axis. So 1, 2, 3, we move to the left. And then 7, we go up. 1, 2, 3, 4, 5, 6, 7. I know that you guys might have had to add on a few more to your plane so that you could get to that point. And we end up with this one being 6. 7 we have, is that 4, 4? So 4 is positive. We go 4 in the right. 1, 2, 3, 4. 4 up. 1, 2, 3, 4. And that's going to be 7. And then 8, negative 1, negative 6. Left 1, down 6. 1, 2, 3, 4, 5, 6. And that's going to be number 8. Do you guys have any questions on plotting those points? I know we did them on the board. Any questions at all? Okay. Section 1.5 is going to be about segments and their measures. And our first part is a coordinate. So a coordinate is a real number that corresponds to a point. So we just plotted those points according to their coordinates on the coordinate plane. We also have distance. That's the absolute value of the difference between the 2 points. We have length, the distance between the endpoints of the segment. And then we have betweenness, the collinear points and the position of the points found within the endpoints. Let's try that again. Betweenness, collinear points, and position of points found within the endpoints. Congruent segments. These are segments with the same length. So we talk about congruence. We're talking about the same measure each time. So our postulate is if B is between A and C, then AC equals BAB plus BC. If you notice this, none of these have lines above it. And I'm not going to tell you to add lines to it because when we're talking about distance, we don't put a line above it. So with no line above that, we're talking about the distance or the length. So here, I'm going to draw a picture that corresponds with this. You see we have So with our picture, we see that our total length AC is comprised of the parts A, B, and BC. So if we add those 2 parts together, we end up having that total length of AC. Do you guys know which state this is? Which one? Not Alabama.
Georgia.
This could be Georgia. But it does kind of have a similar look. I'll give you that one. So if we're here and we want to talk about going from Athens to Albany, right? We want to talk about that whole distance. So if we're interested in that, we want AB equals, and then we talk about the sum of its parts. So AM, Athens to Macon, plus the distance from Macon to Albany. So we always write that statement first. Total equals sum of parts. And then now we can substitute in. So our first part from Athens to Macon, we have 80. Okay, what is it from Macon to Albany? It's 90. So if we add those together, what's our total going to be? Yep, 170 miles. So we end up with that being a total of 170 miles, but we always set it up in that same fashion. Okay, so when we begin this, we talk about the total distance. So what's the total distance? How do we represent that with letters? Yep, PR equals sum of parts. So then we have, anybody? PQ and nice job. So then we talk about the sum of parts, the two furthest away, and then the parts that make up that whole segment. So then we can substitute in what we know. We know that PR is what distance? It's 12. And then we were interested in PQ, so we leave it as distance of PQ. Plus, what is our distance of QR? Yep, it's at 7. So when we want to solve this, what do I have to do now? We're going to subtract that 7 right over. Yep. So PQ equals, what is 12 minus 7? 5. Nice job. So we have a distance of 5 for that segment PQ. Who would like to try it? Yep. Quan? Exactly right. Nice job. AC equals 20. Very nice. Did you guys agree with his work? Awesome. Okay, so the second one I put up here is an extra example. This one is just slightly different than the other ones. Our first part here is we know that the distance from B to C is 11. And we know on the number line that A is at -2 and that C is at 13. We want to find the distance of, so find AB. So take a second and draw this on your page like it is here. You don't have space for it, so just add it to one of the spots on that same portion of examples. I want to make sure you see this. So I know you don't have it on your page, just make sure you're adding it on. Did everybody already do that? Okay. Okay. So we're going to write that first statement again. Who can tell me how to write that first statement? Somebody over here. You guys got this too. Yeah, Jasmine? So you're close. So you're trying to arrange it so you can solve what you're interested in. But we have to write it the whole segment first. So what's our whole segment? You've got this. A2. So the whole distance to go from 2. You got it. I believe in you. You know this. Somebody want to help her out? What's the whole distance we have? Yeah, Sierra? AC. Now that we have AC, now you can tell me those parts that you just had. So with those parts, what did we get? Anybody? Over here? Hina? AB plus BC. Over here, we have that now. Only one of these we have explicitly. Which one is directly stated? BC. So here we see from B to C, and we know that this length is going to be 11. Okay, so looking at that, we're trying to find the distance from A to B. We don't know what that is, so we bring it down. But there is a way to figure out the distance from -2 to 13. How much is that distance? If you're looking on a number line, how can we find the total distance from -2 to 13? What'd you say? We can just count it. You can just look at what the absolute values are there. But you'd be on a number line, you'd have -2, and then you go 1, 2, 2 distance. And then on the other side, you'd have 11. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? So how much is that distance to get to that 13? So how much? 15. So yep, from 0, somewhere in here we have a 0. From 0 to 13, it's going to be 13. From 0 to -2 is 2. When we combine those, we do get the 15, just like she said. And then now we have a problem we can solve. So we want to get AB by itself. How do we get AB by itself? Subtract 11. And we're left with? 4. So the distance of AB is 4. To plot the points and then decide whether A, B, and C, D are congruent. So that was one of the vocab words I just gave you. What does it mean to be congruent? Okay. And so now we're talking about congruent. So that's what I was asking you before we paused. So on that first page, what's the definition of congruent? Yep, Desmond? Exactly right. Segments of the same length. So we're talking about same distance, same length. So the way we do that is we want to count these. So what is the length of AB? So we go 1, 2, 3, 4, 5. The length of AB is 5. So here we have 5. Okay, what is the length of CD? So go over here. 1, 2, 3, 4, 5. What's the length? It's 5. Are those the same? So does that mean they're congruent? Yes, it does. So we have a symbol for that, so we don't have to write out congruent each time. So we write AB. Now we're talking about the segments, so you put the line on top. So segment AB is congruent. It looks like an equal sign, but then we put like that little squiggly mark on top. It's congruent to CD. So when we talk about congruence, we're going to be using this symbol all the time. So same measure, we can use the congruent symbol. Next up, we're going to be plotting some points again. We have A at 0, 5. So take a second, plot yours while I plot mine. B is at 0, -1. Over here, we have C at 4, 0. And we have D at -1, 0. Okay. So now we're going to see if they're the same length. So AB, we have 1, 2, 3, 4, 5, 6. Is that the same length as your AB? Okay. Next up, we want to find CD or DC. And we talk about that length. 1, 2, 3, 4, 5. Are they the same? No, they're not. So are they congruent? Nope. So we're going to write that AB. The congruent symbol, how did we say it's not equal? What do? We put the slash on it. Same thing here. Is CD or DC Remember, we're talking about the segments in each of these, so I put the lines back over it.